Today's video is on solving right triangles, and it's probably stuff that you guys are already familiar with, but it should be a review. And then we'll add in some things like radians to make sure that it's a little more applicable to what we're doing now. So in the warm-up, we're going to draw an angle of 135 degrees. And remember, we know that this up here is 90 degrees. And this to the left is 180 degrees. So 135 degrees is going to be right perfectly in between these. So we're going to draw that ray there to show that angle. So this angle here is the angle of 135 degrees. What I'd like you to do on the Edpuzzle is go ahead and put in the answers for B, C, and D. Convert 135 degrees to radians, find a positive coterminal in radians, and find a negative coterminal in degrees. Type those answers in and then move on. In part E, it now asks you, and this is going to be a really important skill for the rest of this trimester, it asks you to make a right triangle by dropping a vertical line from the terminal side to the x-axis. We are going to do this a whole bunch in this trimester, and we always make our triangles by dropping from the end up or down to the x-axis. We never go over the y-axis. This creates a right triangle. There's an angle here. I know that this angle here is 45 degrees because 180 minus 135 leaves me with that chunk there. And I know that if that's 45 and that's 90, that this one must also be 45 because the sum of the angles in a triangle add up to 180. So this is a 45, 45, 90 triangle, which is actually a special triangle. It has some special properties, like we already know the ratios of the sides and things like that. And we'll talk about that more in tomorrow's lesson. Now, moving on, some things for today. The first of all is the 6 trig functions. You're probably familiar with these first 3. When we talk about SOHCAHTOA, that is a shortcut to help us remember these sine, cos, and tan ratios. So sine of an angle is the opposite side from that angle over the hypotenuse of that triangle, etc. And we have a cos and a tangent as well. You may not be familiar with these 3 on this side. These 3 are what we call the reciprocal trig functions. These 3 are the reciprocal trig functions. We don't deal with them a lot this early on, but we will get into them more as the trimester progresses. So we want to be able to introduce them here. CSC is short for cosecant. And this is the reciprocal of sine. What I mean is this is what sine was, opposite over hypotenuse, but now flipped. Hypotenuse over opposite. And all of these are reciprocals. SEC is short for secant. It is the reciprocal of cosine. And then cotangent, COT is the shorthand, is the reciprocal of tangent. So you may see these, I think especially they're in the apex tonight, and we'll start to see these and we'll use them more, especially as we get into solving and other things. Today, our focus is more on the first 3. We want to talk about solving right triangles and what that means and how we do it. So first of all, what does it mean? Solving a right triangle means finding all of the missing sides and angles. So whatever you don't have for the triangle. I'd like to point out that today we will only be working with right triangles, and these trig ratios above, SOHCAHTOA and the reciprocals, only work on right triangles as well. So those do not apply if we do not have a right triangle. Helpful tools that you can use while you're solving are the trig functions that are listed above. Since it's a right triangle, you could use any of those. And then also we will find ourselves using the Pythagorean theorem, which hopefully you guys remember as a squared plus b squared equals c squared. It's getting a little hard to write on here, but hopefully that's showing up okay. Pythagorean theorem. There we go. So let's do a problem together. In example 1, we are asked to solve the triangle. I know 2 angles. This first angle is a right angle, so it's 90. This second angle over here is the angle 25 degrees. And 90 and 25, if you add those up and subtract from 180, you get this angle that's left here. So this angle theta has to be 65 degrees. I'm just subtracting the other 2 angles from 180. So if you know one of the angles in addition to the right angle, you can easily find the other angle. Now, how about the sides? To find the sides, x, and I'll call the other one y, use those trig ratios. So I'm going to go ahead and set up, and you can kind of set up whatever you want here. So I'm going to go ahead and set up for mine. I'll use cos of theta. Cos of theta. Cosine of this angle, which I do know exactly is 65 degrees, cosine is adjacent over hypotenuse. From that angle, adjacent is the one touching it that's not the hypotenuse, so that's the 3. And then x is the hypotenuse. The hypotenuse is defined as always being across from the right angle. And so we set this up. Remember that we found theta to be 65 degrees. And then we go through and we just do a little solving here. Now, 2 things. You do need your calculator to solve this, and you need to make sure your calculator is in degrees. So if you are getting all wrong answers today, please check in with your teacher to make sure that you have the setting correct, that it is on degrees and not radians. If it's not and you can't figure out how to change it, you can always reset the calculator as well. And that's usually the default. To solve for x here, just multiply x to both sides, and then you can divide the cos. I believe you'll end up typing in 3 divided by cos of 65 degrees. And the answer I want to say I'm getting is about 7.1. So make sure you guys get there for your answer as well. Now, a couple options to find y. One option is I could use Pythagorean theorem, in which case y squared plus x squared, which I just found, y squared plus 3 squared is equal to x squared, which I just found. Well, one issue with this is if your x is wrong, then now the whole thing's going to be wrong. And also your x is rounded. So if you plug it in, you have to use the unrounded. So this is an option, but it's not my ideal option. What I'd rather do is probably just use another trig function. I'm going to go ahead and try tan of 25 here. So I'm going to do tan of 25 degrees. Tangent is opposite over adjacent. If I'm looking from 25 degrees, opposite or across from the 25 degrees is the side length of 3. Adjacent, meaning the one touching it that's not the hypotenuse, is going to be the y. And then I go through and I multiply y over and I divide the tan, and I think you'll get to something that looks like this. Again, type this in on your calculator. You should get an answer of 6.4. If you are not getting these values, then probably your calculator is set in radians and not degrees. A quick Google can help you. It's right in the mode button, I believe, or we can help you with that in class tomorrow as well. In example 2, I'm going to go ahead and work out one more of these. I'll do part B, and then I want you guys to do part A. In part B, you'll notice that I don't know either of my angles. I don't know this angle X, and I don't know this angle. I'll just call it theta. So I can't just start subtracting from 180. I also need to find this missing side. I'm probably going to start off by just finding the side with Pythagorean theorem. Since I know the other 2 sides, and they're not rounded or anything, I might as well use Pythagorean theorem there. And if you apply that Pythagorean theorem, I believe you get a side length of y to be 6.4. Now let's find each of those angles. I would rather, when I find the angles, not use the 6.4 in case I made a mistake and it's wrong. So let's go ahead and do tan of theta, because that one will not use the hypotenuse. Tan of theta is opposite 39 over adjacent 14. Now to solve for an angle, what you have to do, if you have to use the inverse tan button on your calculator. So to get theta by itself, you do tan inverse of 39 over 14. And you're going to type that in on your calculator, and you should see that button right there. But again, if you have any questions on the calculator, come back to class and check in with your teacher about the calculator usage. And the value you should get for that angle is 70.3 degrees if I'm looking at my correct answer key. Now from there, you could go 180 minus 90 minus 70.3. But again, if you had a wrong answer, you would now lose credit on the next x as well. So another option might be just go ahead and go back to x and use tangent for x as well. So tangent of x, opposite x is 14, adjacent to x is 39. Apply the tan inverse to both sides. And when you do tan inverse of 14 over 39, I believe you will get a 19.7 degrees. So I check and I make sure all my angles add up to 180, and they do, and I feel pretty good about that. Go ahead and type in your answers to 2A, pause this video, work it out, and then put the answers into the Edpuzzle. Now moving on to example 3. 3, I'm going to work out 3 of these with you. Now, this is the same exact problem. The only difference is that we have now oriented these on an XY axis. So all these problems live on an XY axis, and you can compare it to where the origin is. So when I solve the triangles, there's an extra thing I can do. I can now find coordinates of a point on the triangle because it has an XY position. So I'm going to do the same thing as normal. In this first problem, I see that since this angle is 127 and I know all the way across would be 180, I can subtract those and I'll find that this inside angle is 53 degrees. Of course, this is a right angle here. So if I subtract 53 from 90, I should get this other angle here to be 37. So 53 and 37 are my angles, just doing some subtractions from 180 type of work there. Now, remember, any questions that you have in this video, you can pause at any time and come back to class and check in. Let's talk about finding the sides here. They told us that side AB is a length of 38. I do not know the other two sides, so I'm going to go ahead and call those X and Y. Notice how I put X on the X-axis and Y along the Y-axis, just because I thought that made more sense. So let's go ahead and find these angles, these sides. So I'm thinking, I know the angle of 53 degrees. I'll maybe use like sine or cosine. So sine of 53 degrees is opposite, which is my side Y, over hypotenuse, which I know to be 38. Cosine of 53 degrees is my adjacent side, which is X, over my hypotenuse, which is 38. When I solve each of these, I should get a Y value of 30.3. And I should get an X value of 22.9. So I'm doing the same math I did before. I'm solving to get the missing sides and the missing angles. Now, this last part is important, so make sure you hear me. On this last part, it says, find the coordinates of this point B. So the coordinates of the point B, notice I went left, so this X value needs to be a negative 22.9. And then I went up, which is a positive direction. So the Y can still be positive 30.3. So this is actually the final answer here for your answer in part A. But we really got to pay attention when we're on the XY plane about positives and negatives. Don't use them on the triangle per se, but use them when you guys are identifying the coordinates especially. Part B and part C, they're both going to be positive since they're right and up, so you won't have to worry about that. I'm going to leave both of these for you to do. See if you can, you should all be able to do B, no problem, and then see if you can figure out C as well. And what you should notice is these are actually both special right triangles, which we will work more with tomorrow.